In this video, we're going to discuss the normal distribution. This is a continuous distribution that is symmetric, bell-shaped. It follows the empirical rule, which we've already discussed. And so what it is if I draw a bell-shaped curve down here, a couple of things we need to know about it is that it is symmetric, just like we've discussed before. So if I fold one half onto the other, then they will be on top of each other exactly. The mean, median, and mode are equal. So the mean, median, and mode are all right here. The mean, median, and mode are all in the center. So the mean, median, mode, they're equal. The total area under the curve equals up to 1. Remember in previous distributions and the probabilities, things like that, we've discussed that when you're looking at the probability of all the possible outcomes, they have to add up to 1. Same thing here. The whole area has to add up to 1 or 100%. And the normal distribution follows the empirical rule. If you'll recall, what we said about the empirical rule was that we put the mean in the middle, and then we go out and we say the mean minus 1 standard deviation and the mean plus 1 standard deviation. And in between here, in between 1 standard deviation away, this was 68% of our data, approximately. So about 68% of our data lied within 1 standard deviation of the mean. Then we went out to 2 standard deviations, so minus 2 standard deviations, the mean plus 2 standard deviations. So this included the middle 68 and added this part on. So we're adding all of this on. And this was about 95% of our data. Okay. Lastly, we went out to a 3rd standard deviation. So the mean minus 3 standard deviations and the mean plus 3 standard deviations. So we've got these portions. And this was 99.7% of our data. So between 3 standard deviations away was 99.7% of our data. That leaves these little bitty tails with very little in their amount in them. Now obviously I did not have this drawn very well because I've got a larger tail over here, but you kind of get the idea as long as we're going out the same thing. We're going to be using this quite a bit, and the reason why we use this is for a specific type of distribution, and that is the standard normal distribution. We've actually already discussed the standard normal, which is the z-score. The normal distribution, standard normal distribution is a normal distribution that has a mean of 0 and a standard deviation of 1. So we have a mean of 0 and a standard deviation of 1. So that means whenever I draw this out, and see if I can do a better job of it, my mean here in the center is going to be 0. My standard deviation is 1, so if I go the mean plus 1 standard deviation, that's just a positive 1. And the mean minus 1 standard deviation, that's a negative 1. And I continue on with that. I get a -2, -3, +2, +3. These are my standard deviations out just like on the previous slide. Therefore, between these two, there's 68% of the data, but usually we mark that in half because we always divide this, and so that means that there is 34.13% about in each portion. And these are approximations. And we're going to look at a table that's going to help us find these actual approximations. When I put here, we've got 13.59%, 0.59%. We have 2.15%, 5%, which leaves us with about 0.13% on the ends. And these numbers you don't really have to memorize. Like I said, we're going to use a table that will help us to look at these. But we do want to make sure that we remember the formula for the z. Remember that the formula, which is the standard normal distribution, because we always want to standardize everything when we're talking about any type of application, we have to standardize it, and so we take the value minus the mean divided by the standard deviation, which translates into x minus mu divided by sigma if we're talking about population, or x minus x bar divided by s if we're talking about a sample. We will definitely be using these in later videos, just to reiterate what we have already learned. Now then, to find the probability or the area underneath the curve, like I have put here, these areas, we're going to use a table. It's called the standard normal distribution table. The first thing that you always want to do, though, is make sure that you draw and shade the area first. So what we're going to be looking at is this table, which you can find in your textbook. And a couple of things about this table: you actually have two pages to this table. One will have negative z values and the other will have positive z values. And across the top also has the z values. Z values are always given to you in 2 decimal places. You always want to give z values to 2 decimal places. And what you're going to do is you're going to find the whole number and the first decimal in this left column, and then you'll find the last decimal along the top column, the top row. When you do that, you will then see where they intersect, and that will give you the area always to the left of your z. If you notice this picture down here, it always gives you the area to the left of the z value. So we'll kind of look at some and practice how to get the z's, the areas, things of that nature. But we always want to make sure that we're using these tables. So let's first look at if I want to find the area to the left of z value. In that case, I'm going to draw the picture. And it doesn't matter, it depends on what I'm looking at. I always kind of draw the zero, the mean in there, just to kind of make sure that I know what I'm doing. Here's my 0. And let's say that this one was a negative z value, a negative z. I shade to the left. This one was a positive z, and I shade to the left also. When I do this, the probability of z being less than whatever number is given here is equal to the area on the table. So I literally look up the value in the table, and that is my answer if it's to the left. Now the difference becomes when I want to find the area of, area to the right of a z value. Here, I'm still going to draw the picture like I did previously. So if I draw my picture, and I'm going to draw it both times and put my 0 in the center. Okay, and here's a negative z. Oh, I want to the right, don't I? Ha! I want to draw to the right of it. So let's draw to the right, shade to the right this time. And a positive z, shade to the right. What you have to remember is that the table always gives you to the left of the z. It always gives you this area. We want the other side of that. So what you're going to do is, this is the probability that z is larger than a number because it's greater than the number. That is going to be equal to 1 minus the area on the table. So you look up the value on the table and subtract it from 1, because remember that this whole thing adds up to 1. The table gives us this part of it, so we're going to subtract it from 1 to get the part that I want. Okay? And we'll do an example or two of this in a moment. Let's look at one other possibility, and that is if I want to find the area between two z values. If I want to find the area between two z values, so And I'm going to draw 3 different pictures here because we have a couple of different possibilities. Let me give myself a little bit more room here. So here's me some normal curves with my mean in the center. One possibility is if I want between a negative z and a positive z. So I want to know, what is this area right here? Another possibility is if I want to know the area between this z and this z. Another possibility is if I want to know the area between these two negative z's. Remember that the table gives us to the left of any z. So what we're going to do is we're going to look up this z, and it will give me to the left. Then we will look up this z, and it will give me to the left. If I will subtract the numbers, that will give me what's between them. You have to be very careful. Do not subtract your actual z's, only subtract the areas. Make sure you're only subtracting the areas. And when you do this, the probability that z is between two numbers is equal to the largest area minus the smallest area. Make sure that your probability comes out to be a positive. You cannot have a negative probability. So always make sure that you take the area for the one on the farthest right minus the area for the one on the farthest left. Again, do not subtract the z's. Look it up in the table before you do the subtraction. Very, very important. You don't actually subtract the z's. You look up the areas first. Let's look at an example or two. We want to find the area under the standard normal curve to the right of z equal 2.01. Okay, first thing is we're going to draw the curve, and we're going to put 0 in the center. 2.01 is going to be somewhere over here. We want to the right of that, so I'm going to shade to the right. So for this one, we're looking for the probability that z is larger than 2.01. If you're confused on which greater than, less than sign to use, look at which side is shaded, and that's the direction this little thing should be pointing. So since I want to the right, remember I'm going to do 1 minus the number that I look up. So I need to go down and look at my table. We're looking at 2.01, and it's a positive. So I come to the table, and my z is 2.01. So z 2.0 is right here, and the last one is right here. So I find where these two, this column and this row intersect, which is right here, 0.9778. And that's what I put, 0.9778. 9778. So the probability that z is greater than 2.01 is equal to 0.0222 once I do that subtraction. Normally we have rounded our probabilities to 3. Since our table gives us 4, we're going to leave them with 4 decimal places, because that is what our table gives us. Okay. This is one that we had to do subtraction because it gave us to the right. Let's look at another example. This one, I want to find the area under the standard normal distribution curve to the left of z equals negative 0.96. Okay, so let's draw a curve, and boy, that curve looks horrible. Try that again, and that's not much better. 0. Negative 0.96 is going to be over here on the left, kind of close to 0. And we want shaded to the left. So I'm going to shade over here. So we're looking for the probability that z is less than negative 0.96. When we want a less than, this is what our table gives us, so I can just look up that exact number, and that is my final answer. So I'm looking at the negative, so I need to look at the negative version of the table. And again, we were looking at z being a negative 0.96. So I come here to the negative part of the table, and I look up for 0.9, which is right here. So in this row, right here, and the 6 is going to be here. So I look at this column and see where they intersect. They intersect at 0.1685. So I get 0.1685, and that is my answer. Again, if it's to the left, less than, I don't do anything. I just look it up and I stop. That's the nice thing about less thans. Greater thans, we've got to do a little bit more calculation. Let's look at one more example. This one is, I want to find the area under the standard normal distribution curve between z is equal to 0.24 and z is equal to negative 1.12. So this one is in between. So we're going to, here's 0, and nope, let's see here, negative 1.12 and 0.24, and I want between these two numbers. So when we're looking at this, we want the probability that, and we always put our negative number first, or our smallest number first. Z is between these two numbers. And that actually gives us a little bit of a problem when we do our calculations. But what we're going to do is we're going to look up negative 1.12 first. And let's see here, negative 1.1 is here, and the 2 is here. So if I follow that over, gives me a 0.1314. So this is going to be 0.1314. Then we want to look up this area here, which is the area for 0.24. So I have to use the other table over here. So I look up 0.2 and then look up the 4. So we're here, 0.2. So it's going to be the 0.5948. So this is 0.5948. Again, because I want between, I want to do the subtraction. So I take the largest of the areas, the one that is farthest right. So I'm going to do 0.5948 minus my other area, which is 0.1314. When I do that subtraction, I get that the probability is 0.4634. So the probability, or the area between those two numbers, is 0.4634. If you change that into a percentage, it's 46.34%. And again, our table gives us all the decimal places, so we do want to keep all those decimal places. Now the tables can be used in a different way. They can also be used to find the z-value if you're given an area. If you're given a percentage or an area, you can find the z-value. So far we've been going from the outside and following it in. How we find this is when we are given an area, we need to find it in the center of the table. In the center of the table, and follow it out to the z-value. This is completely different than what we have been doing, but if we look at our table, remember that these are the areas inside here. And so if we're given one of these areas, we find it, which takes a little bit more time because it's not as easy, and then we follow it out. One thing is, if it's less than 0.5, it's going to be on the negative table. If it's greater than 0.5, it's going to be on the positive table. And you can kind of follow it. It does go in order, so you can follow it through and know, okay, I'm getting close, or no, I need to keep going. So it will be a little bit easier for you to find once you know what you're doing. So let's look at this example. Find the z-value that corresponds to the given area. We have this to the left, and the area is 0.5478. So I want the z that corresponds to this area. Since it is to the left, I'm just going to look up that value, and that's it. Now then, it's greater than 0.5, so I'm going to be looking at the positive z chart. And I'm looking for 0.5478. 0.5478. So I start here, and here's 0.5, and I keep going, and I'm looking for 0.54. Well, here's 0.53, so I go to the next row, 0.5478, right here. Right here is the area that I'm looking for. So I follow it out and follow it up. So my Z is going to be 0.1, and that last number is my 2. So again, you're looking at the center and then following it out, remembering that these are your first two numbers and this is just your last number. You don't actually use that extra 0 in there. Practice some of these and let me know if you have questions.